We've got one more section to do today, vulnerabilities, threats, and countermeasures. So emanations are one big one. The project, a U.S. military project called Tempest, checked to see what is the radio emitted by computers and at that time the CRT screens, and they found it's really bad. They emit a lot of radio energy, so much that you could easily reconstruct everything on the screen, and they concluded that the only way to make a computer safe is to be inside a room with metal all around you and no windows. You have to sort of be in a specially built, secure place, and that's how we ended up with SCIFs, these special rooms. For information, it's not easy to prevent an attacker from seeing what's going on a computer. And these are covert channels. I mentioned before, these are communications that violate the security policy. You might have a storage channel where you can share some shared storage on a machine, like the temp folder might be shared by multiple processes and older versions of Linux systems. And there might be a timing channel, like the time to reject a username is different from time to reject a password, that sort of thing. Or so your encryption time might depend on the key and input. This is one of the many flaws. You might be able to deduce something about the key from the time it takes to encrypt and decrypt. There are backdoors that bypass security checks. There are maintenance hooks. This keeps on happening. It happened something like 8 times to Cisco a few years ago, and I see it come up quite often where there is a secret username and password in the system that nobody told you about. Now, this wasn't, if you see the movie Tron from like the 1980s, the main character knows that his father always used a certain password for backdoor. It was a common practice way back then, but it's no longer acceptable. There's a time when this was how the tech support people would get in, but it's a ridiculous risk, and it keeps on happening. They called that a maintenance hook. You might have that in some kind of production, some kind of testing system, but you shouldn't have that in the system you actually sell end users. If you do, it's a security vulnerability and you'll have to patch it. And then, of course, all the malware. Most things these days are Trojans and worms, and those zero-day exploits are vulnerabilities which cannot be patched because nobody knows about them. And there are a lot of people have these. The Chinese government has a lot of these. If you have good security researchers, you can find things that nobody knows about, and they're, of course, very deadly. A maintenance hook, default config, that's right. Cisco kept on having maintenance hooks in their product, default passwords, and a lot of other people it happens. So viruses are code attached to an exe file. These were pretty common in the days of floppy disks and such. Technically, the modern attacks are not really viruses anymore. They aren't executables running in the same sense. What they are is worms that propagate over a network where they send out instant messages or emails or something to spread. Trojans lie about what they do. They deceive people into installing them. This is quite common. One of them just got a major cryptocurrency developer. He said for 10 years he's been a cryptocurrency researcher and investor, and he never got hacked, but there was an extension for the Cursor coding platform that had a good reputation, and he installed it and installed all his crypto. That's the thing. Any code you install could do anything on your system, and if you don't have some way to verify that it's clean, you're taking a risk. Rootkits replace part of the kernel or operating system, so they run at the low level. They're very difficult to detect and very difficult to remove, and give the attacker long-term control over your computer. And there's packers that compress and obfuscate executables so the strings are not readable. We use these quite a bit in the malware analysis class. And there's a decompressor. A UPX is a common one, so it automatically unzips into memory and runs, but while it's stored on the hard disk, it's compressed and the strings are unreadable. And then there's logic bombs that wait for a certain date on a network system. These are usually custom written. They're very hard to detect. And of course, we had antivirus software around forever with a database of signatures. The problem is nobody wants false positives. You don't want it to trigger on an innocent program. So all they usually do is look at known bad programs. And all the bad guy has to do is modify the program a little bit, and the signature won't match anymore. So these things are important, and they stop a most common kind of attack, which is an attack where they would mail the same file to 1 million people, but it's very easy to slip past them. So now they try to have heuristic detection, where it detects anomalous behavior, like something unzipping in a suspicious way, but when you do that, they typically have false positives. Now they'll trigger on innocent software. So the antivirus, there's a time, maybe 10 years ago, and most people believed antivirus worked, therefore there's no viruses, no malware on any of the machines. Now we've gotten over that. Now we know that even if you run antivirus, it's possible to get past it. So there's server-side attacks that attack your vulnerable services on the server, like your SMB file sharing on port 445 is common. Find a way to upload a malicious file. Client-side attacks run code on the client. So they trick you into downloading malicious content like a PDF file or a Word document or something, which has unexpected evil code. The web architecture makes a whole lot of new attacks on the server side possible. The problem is there are many different technologies being used at once on the web. And PHP in particular is famous for remote file inclusion. You very often have a structure like this. You have a PHP script, and then the file name is a parameter. And so you can change the parameter to point somewhere else, like an unexpected file on this box, which is local file inclusion, or you can go to another server, remote file inclusion, and now this web page will get data from another server where I can put up an evil script. This is a common flaw of PHP-based code. Java applets, not used that common anymore. People used to use Java applets that run in a Java plugin, and ActiveX was Microsoft's competitor. Both of these are rarely used anymore. There used to be something called Flash 2 that did this. Now HTML5 makes it possible to do all this natively. OWASP is the open organization of security professionals from many major companies, and they define how to secure the web. And they have a lot of the most popular thing they do is the top 10 vulnerabilities of web applications. And, you know, the web hacking class that's going on this semester here, we go through all this stuff. You practice attacking and detecting all these things. So service-oriented architecture, you have a lot of services. Now, your Windows operating system has about 100 services running in the background, and they provide a service to many different programs. So that's your services, and they can be platform independent, and they're published in a directory of some sort. So web services can take data from an XML or JSON. SOAP is one type of connection. SOAP and REST are ways to format data to move it over a network for one process to talk to another. And there's web services description language, which describes all the services. So this is one technology where you offer many services from one server on the web. Database security is a big issue. You need a database if you have a lot of data. It's all pretty much the same, like a list of products, a list of customers, a list of employees. You store it in a special kind of server called database, and now you can view records. There are inference attacks, and aggregation attacks are threats, where you're able to take low privilege data and deduce something about the high privilege data from it. Inference controls and polyinstantiation are defenses against those attacks. Databases have a primary key, which is a unique identifier of the records, typically something like a social security number or a student ID, or Microsoft operating systems use a security identifier. There has to be some unique way to identify users and other things, so that even if two people have the same name and the same birthday, they can still be distinguished because they'll have a different primary key value. Polyinstantiation is what happens if you have multiple security levels of data in the same record. So there's top secret data tied to a primary key, and there's secret data tied to the same primary key. So if people have secret clearance and they request that record, they'll only get the secret stuff. The top secret people will get all the data. This is called polyinstantiation. A user can infer restricted information. For example, this is a well-known fact, and I've heard it's still happening. All you have to do is see how busy the pizza shops are near the Pentagon at night, and if they're busy, that means a major military operation is being prepared. Everybody's making everybody stay late, and they're ordering pizza. They still haven't fixed this. I heard about it just a few weeks ago. This is an inference attack. A low privilege measurement can tell you something about a high privileged activity you're not supposed to know. Aggregation uses many low-level facts to deduce restricted information. So if you look up every phone number and you see that some phone numbers are missing, those must be the high-privileged ones you're not allowed to see. This used to be a big deal. This is why the movie War Games, that came out in 1980, was about this. And at that time, their networks, they had a PBX, which is a private branch exchange of hardware to handle the phone lines at their company, and they had Cisco routers. And the Cisco routers had an aux port that was connected to one of those phone numbers. And you had these 4-digit phone numbers at your company, and one of those phone numbers led to the router, and if you knew that number, you could control the router. And there was no password or anything because they didn't think it was necessary because they thought nobody could find the phone number. And the thing about the war games is it popularized the fact now that we had modems, you could actually make a computer program dial all the numbers and detect which of them are computers and find the hidden number. So they had to improve that security. But this was, anyway. All right, so what you should do is place your pizza vendors under non-disclosure agreement so they won't tell people how busy they are. Polyinstantiation is an inference control. You restrict the number of queries made as an aggregation control. You don't let somebody ask for all the phone numbers. You say you can only ask for 5 records every hour or something. Then they can't reasonably gather that data. So data mining is searching a large database for useful information. Credit card companies mine transaction records to find suspicious transactions. And of course, a lot of people mine the internet, trying to find customers and try to predict what stock prices are going to be and things like that. And data analytics is here. And I just heard, I was listening to an AI pivot podcast, or it was Kara Swisher's on. She had AI experts talking about AI, and they said, you need to get a data scientist. They said, the problem is you can't find data scientists easily. I'm thinking maybe I should teach a class in data science. I know they have majors in it somewhere. Data science is the field of understanding how to use data and format it. And now that in the age of AI, there's a huge need for it. And I'm going to cover it somewhat in the AI class next semester. You have to do a lot to make the data useful. You can't just take raw data and use it. You have to do a lot of massaging of it. And people who know how to do that are in great demand now. So you can also have defense in depth. This is a general rule. You have multiple layers of controls, like you have technical controls on the network, like passwords and firewalls. Then you have administrative controls, like policies and procedures. And you have physical controls, like locks and fences and guards. And all these make it hard to break into the secure stuff, and that's the idea. If somebody steals a password, they still can't get through past the guard to get in there. That's the idea. Defense in depth. Mobile device attacks are a big issue. Everybody's bringing in portable devices that might have malware and connecting them to your network. And so the defenses, you can restrict the use of them by policy, just forbid people from bringing in their mobile devices. People tried that when these mobile devices first became popular about 10 years ago, and they pretty much gave up. It's hopeless. Everybody has to have their private device, their personal device. What's more common now is to limit what they can do. If you have USB drives, you can disable auto run, and you can only allow the official drive. There's 802.1x authentication, which is a cryptographic authentication that will detect if it's the approved drive and no other drive is allowed to run. There are various versions of that. And of course, if you have a cell phone, mine is this way. My phone is used as the second factor of authentication for one of my consulting gigs, and therefore they have to put a management profile on my phone, and they control my phone. They can erase programs, they can wipe it, and things like that. That's what you have to do. You have to have mobile device management. Anyway, for company phones. So, and then there's countermeasures against theft. You should back up the data, and you should, so that you don't lose the data if they lose the phone. You should have full encryption of the data, so that if they do lose the phone, nobody else gets the data. And you also typically send a remote wipe signal to wipe the data after they lose it. The problem is, of course, some phones are lost, and they never come online again because they really did drop it, in a ditch somewhere. Then you never get to wipe it. You never know what happened. So encryption is your better defense. 802.1x is just another form of authentication. There are various versions of it, but here it pretty much means you have a cryptographic certificate on the device, which is recognized by the computer you plug it into to verify that this is the approved official company device. All right, let's look at 3E. Which is here. I just got a pop-up earlier today before I came in telling me that my consulting company has required me to make some adjustment on my phone. I haven't got what it is yet. Probably have to update a version of something. But that's what they do. They control your device. They can place requirements on what you do with it if it's your company phone. I had TikTok on my phone, and they made me take it off. Wasn't getting any good out of it anyway. I don't understand TikTok. People say it learns to please you. It did not learn to please me. It was like watching TV commercials. I was disgusted. I didn't need it. Apparently, teenagers can watch it all day. I did not have that experience. It was not interesting. They made me take it off. I didn't really care. Well, it could be that, kinda. I don't know. TikTok seems to be the main information source for young people. I don't know. I imagine a lot of it is mindless. Some of it's probably good. I do see some YouTube shorts. Some of those are good, and I think they're pretty much the same thing. There's some serious news commentators that make short ones, like the lightning talks that you're going to give. A 4-minute talk is enough to say something, and TikTok, I guess, is limited to 3 minutes. I'm not opposed to short talks. If you plan them well, you can communicate something useful that way. All right, so what vulnerability does the FBI want to add to iPhones? Ah, yes. This happened about 6 years ago. People may have forgotten it. But in fact, it keeps coming back over and over every year or two. Now it's the UK doing it. They want to have a back door. They want to have a way to get the data off the phone. They sued to try to make Apple give them a back door, and Apple refused, and the FBI case collapsed before the verdict was rendered because it turned out that they had another way to get the data. What they did was they bought hacking tools from Celebrite, or another company that could just hack in the phone and steal the data. So they didn't need Apple to make a backdoor. You can buy a commercial backdoor. All right. But there's now a proposal in the European Union to put software on everybody's phone that will automatically report you if you put child sexual abuse material on the phone. And Apple tried to do that here, but there was a huge outcry from the privacy advocates, and they did not do it. And in Europe, there's a huge outcry from the privacy advocates, and they haven't done it yet, because the problem is they admit there's a 10% false positive rate. So that means 10% of all the people out there are going to get accused of this appalling crime, and it's wrong. And that is probably too much harm to innocent people to justify the benefit you might gain. But they're arguing that out. Anyway. All right, what threat destroys a system on a certain date? Okay, that's a logic bomb. When some condition happens, something undesirable happens. All right. All right, what language tends to have RFI vulnerabilities? That's PHP has remote file inclusion vulnerabilities. All right, it's Celebrite with an E. They're an Israeli company, and they will sell you software that can punch onto any Android phone or any iPhone. I met the CEO in Sri Lanka, and he told me that. He said they can get through any version of iOS and any version of Android. They find vulnerabilities like 0 days, and they'll only sell it, supposedly, to law enforcement and government agencies, although they're trying to expand to corporations when I last talked to them. Maybe they have by now. It's a thing to be aware of. Your data is not all that secret. If somebody pays enough money, they can get it. Which organization makes the top 10 web vulnerabilities? Yep, OWASP, Open Web Application Security Project. Very good organization. Everybody loves them. All right, what attack searches a large database for useful information? Yeah, data mining, a good descriptive term. You have some huge database like, say, the internet, and you're trying to somehow find the good stuff on there. All right. All right. So, stop the recording.